is really looking at the standard deviation. When we talk about standard deviation, we are only going to be talking about normal curves. Okay, so we're not talking about left skew or right skew. We're now only going to be talking about a normal curve. Patrick, have your notes. Soda. Put away your phone. Put your phone away. Okay. So standard deviation, this is kind of a goofy word. What does it mean if something is a standard? It's normal. So if like you're doing the standard, you're doing the normal or the regular, what's expected. It's the standard. What does deviation mean? What does it mean to deviate? Deviate? Yeah, kind of go around. So deviate means like go away from. So it's kind of goofy because standard is like our normal, and then deviate means to go away from. So really what we're measuring is how far away we are from the normal. In this case, when we talk about normal, we're talking about the average. Okay? So, as we write this definition, I'm going to make sure I have my definition correct. Sorry, I didn't have it open. Okay, it's the distance. Okay, and that distance is the deviation part. Deviation, distance. Each data point is from the mean on average. The distance each data point is from the mean on average. The distance is that deviation, and then mean, that's our standard. The standard is the mean. But when we take that distance, we actually end up averaging it to figure out how far away are most of our points. And it's kind of a complicated formula. It's not super complicated. But that formula you're going to practice in Algebra 2. Okay, so when you take Algebra 2, that's when you're actually going to do the formula. In intermediate, we're going to just practice getting the standard deviation and what it means and interpreting it. And the reason why is a couple of reasons. One, it's your first time probably working with standard deviation, so we need to understand why behind it and why it's important. And two, if you ever have a job that you need to do the standard deviation, do you think you're going to find standard deviation by hand, or do you think you're going to use a computer? Yeah, a computer's probably going to do it for you. At some point, it's important to know how to find standard deviation. That also helps you understand the meaning of it, but most times now we just find standard deviation using a computer, but we need to know what standard deviation means. Okay. Kind of the other part that's important to remember about this is it shows us how spread out the data is. Okay, it shows us how spread out the data is. So if we have a large or a bigger number for standard deviation, that means our data is really spread out. If our standard deviation is really small, that means our numbers are really close together. Okay, so it's how spread out that data is. All right, we're going to jump back to Unit J for a moment. And think about those words that we use to describe probability. So if it was a 0, we use the word impossible. What were some of those other words we used? Impossible. Way back in J1 is the very first notes we did this trimester. And And then we had unlikely, even chance. Okay, if Dean Run can't say the next one. What was after even chance?
Likely.
And what was the 100%? Certain. Good, look at that. Amazing. I covered it up. I was hoping some of you would remember it. Okay, we're going to go back to some of those words. So, if a data point is randomly chosen, we're going to kind of think about our probability now. So we're randomly choosing one data point. Dot, dot, dot. Okay, it is likely to be in one standard deviation. Okay, it's likely to be in one standard deviation. Remember, likely, what percent was likely? How much did it have to be at least? 50, yeah. So it had to be at least 50%. It was the majority. So the majority of our data has to be within one standard deviation. So we look at the mean. The mean is in the middle. And then as I work my way out, that's a range. It's from here to here. That's where most of our data is going to be, over 50% of the data. Okay, but now we're going to go another standard deviation. We're going to do 2 standard deviations. So here's the mean. We're going to work out 1, 2 jumps. So we even have a wider range. So we're increasing our range. So we need to increase likely. We don't have a word for an in-between likely and certain. So we say most likely, meaning it's even more likely than it was before. Most likely to be in 2 standard deviations. All right, and then we're going to go one more. We're going to go 3 standard deviations. And we need to go something that's even more than most likely. So we went in the middle. Then we went 1 standard deviation. We made it kind of a wider gap. It was most of the data. Then it was even most likely, so even more, close to 100%, but not quite. What would be even more than most likely? Certain, yeah. But here's the thing is with outliers, we can't guarantee that it will be 100%. So we have to say almost certain. Because every now and again we get that outlier that's going to not quite fit. So almost certain to be in 3 standard deviations. Now, if you're like, what the heck is Miss Morrell talking about? Let's put a visual with it. So you're going to get a glue in. You can glue it in on the left or the right side. If you need to trim the bottom a little bit, you can. All right, as you glue this in, if you want to grab one highlighter or one colored pencil. I'm going to use a highlighter personally, but if you want to use a colored pencil, that's fine. All right, so glue this in on the left or the right side. Not one to look at. All right, so we're gluing this in here. As you glue it in, find one highlighter.
Just one, only one highlighter, that's all you need.
Or one colored pencil if you don't find a highlighter.
Pick your favorite one. Or your second favorite.
Or whichever one you have.
One's available.
I have a green. Green is my favorite though, so. So it kind of all works out. That's what I have. I have was green, and green's my favorite. Yeah, they're like you'd have to dig from there on the bottom shelf of the cupboard. Like how large are you thinking? A gallon? Yeah, there's some in there. Okay. Yeah. Okay. All right, here we go. So, 15 more seconds here to cut this out, get it glued in. See a couple of people trimming, so if you're trimming it, trim, get it glued in. You don't need to cut it out though. Or cut it out, I guess, if you want to be fancy. I'm not cutting it out. What are you doing? So much. So fancy. All right, so as we take a look at this, we have two examples that we're going to go through. This first one is just going to be kind of our basis idea, and then we'll actually do it with an actual example of what we did yesterday. Okay, so remember this is a normal curve. What? You aren't doing the formula. You have to do in parentheses x minus the mean, parentheses squared, plus all the other ones. You have to do all the points, and then the square root of that divided by the number of points. Okay, so in this one, it's a normal curve. What do we know is in the middle of our normal curve? There's three things that are always in the middle of a normal curve. The median, the mode, not the maximum. Median, mode, and mean. Mean, median, and mode. Maximum would be over here on this side. That's the maximum. Okay, so middle is mean, median, and mode. What we're going to focus on is the mean. Because we use mean so much in math, we have a special symbol for it. It's this. It's an X with a line above it. And because mathematicians are super creative humans, we call this X bar. Hi, how are you? It's good to see you.
Oh yeah, I have my friend over.
Moody Leaf's here?
Yeah.
Okay, wave at him for me.
Symbols are
Okay, bye, Idris.
they're like their own language.
Yeah. All right, so X bar, super fancy. Okay, and that's because if you could study data and stats, you use that so much that anytime you just see X bar, you know that is mean. Okay, and that goes in the middle. Yep, X bar. So it's an X with a bar above it. X bar. All right, then we're going to do SD today, which is going to stand for?
South Dakota.
Nah.
What do you think it stands for? SD.
Southern Dakota?
Super duper. What did we just talk about? Check your notes.
Literally, we wrote it 1, 2, 3. We've written it 4 times already.
Yeah.
Ah, there we go. Standard deviation. Okay, now we're writing it here. Shh. It might feel like it's a little obvious, like, well, of course SD stands for standard deviation, but one, as we just heard from the class, you guys did not all automatically know it. And two, sometimes when you take your test, you need that extra reminder because sometimes during a test you're not thinking clearly because your heart rate is elevated. So having that reminder is going to help us. Now, in math, we use this X bar for mean. For standard deviation, we use the Greek alphabet. The Greek alphabet is different than the English alphabet. It doesn't use A, B's, and C's. It has different symbols. Similar to like Arabic has different symbols than our alphabet. If you compare the alphabet, English alphabet with the Arabic alphabet, they don't look the same, right? Okay, so the Greek alphabet, it looks like an O, and then there's this little extra tag on the top. It almost looks like an extra guy wearing a hat. This is called sigma. It's a Greek letter. We're not going to use that this year. I just wanted to kind of include it as like a fun little fact. It's called sigma. Once you get further and further into calculus and stats, you use more and more Greek letters. Okay, as a math major, me and my friends had a game where we printed out the Greek alphabet and we checked off every time we learned a new Greek letter what it stood for. We almost got through the whole alphabet. Not quite.
How do you spell that?
What? This is sigma.
How do you spell it?
S-I-G-M-A. Sigma. And this is lowercase sigma. Uppercase sigma looks different.
How's it look?
Uppercase sigma looks like this, but that has a different meaning in math.
Oh my gosh, you're creating really hard memories for me. Please
Are you?
erase them.
Okay, sorry. All right. So as we go with standard deviation, as I move to the right, that's going to be one standard deviation. This next line is representing that. So this is going to be a +1 SD. Okay, so here's my mean. I have a standard deviation. As I go to one to the right, it's +1. What if I go one to the left? -1, yeah, or -1. Okay, so that's where most of our data is. That's where that likely is. Over 50% of our data is in those two columns.
Sure.
Yep, over 50. We're going to learn the exact number on Monday. All right, Ian, show for a sec. Thanks. It's really distracting. Mostly to me. Okay, now we're going to go another standard deviation out. So now here we have a +2 standard deviation. And on the left side, it would be -2. Okay, and it's all starting from the mean. So that's where we're getting the 1, is if I start at the mean. Here's my average. This is where more than 50% of our data is. This is, if it's a normal curve. If it's in this, then that's our most likely. If we were going to round, it'd round up to 100%. It's not quite 100% yet. It's not enough that we can say it's really, really close to 100%, but it's most, like a lot. Okay, then we go one more out. So then we have our +3 standard deviation
How does it go out?
and our -3 standard deviation.
How far does it go out? Just two?
Just 3. You can go more, but 3 is where almost certain. So with 3 standard deviations from here to here, it's almost certain that 100% of our data is between those numbers. Okay, I can't guarantee it because we have outliers here and there, but almost 100%, almost for certain, will be between that. All right, so we're going to do that with our Chips Ahoy cookies that we did yesterday. Okay, so for Chips Ahoy cookies, now this is what I actually did real data with. Now we had decimals, I'm just going to round. So yesterday with Chips Ahoy cookies, our mean was 19. I think it was like 18.5 or 18.6. So I'm going to just round to 19 to make it easier for this first one. When I put it in the calculator, in my standard deviation calculator, again, I didn't do it by hand because that takes a long time. There's calculators that do it for us now. Okay, but once you're in Algebra 2, you will do it by hand. Right now, it's okay to use a calculator. Standard deviation was 5. And again, that wasn't quite 5. It was like 5.2. So it's a little off, but we're just going to round. All right, so our goal here is to label this number line on the bottom of the graph, where these numbers go. We always start with the middle number, because what do we know is always in the middle of a normal curve? 3 things.
They all start with the same letter. 3 things. What's one of them? They start with M. Jason, what's one? Start with M.
What's in the middle? X
Yes.
bar.
Yes, it will be.
It'll be X bar.
What does X bar stand for?
What's the, starts with an M.
Money.
You just wrote it down.
Monkey.
You're close. Yes, exactly. You got one. Nice
Mean.
job.
What else is in the middle? Median and mode. Good. Nice
Mean,
job.
Median mode.
So here we know our mean. What is our mean? 19. If you need to write that word underneath this, just remind yourself the mean is 19. Okay, that's what I'm using my highlighter for, because that's how we set this up. If we don't put this in the middle, there's no way you're going to be able to do the rest of this. You have to start at that middle, at that mean, 19. Now, our standard deviation is 5. So as I move to the right, my number line is going to count by 5s. So as I go to the right, I'm going to add 5. So what is 19 plus 5? 24. Okay, so that's our goal, is to number these. Again, we're going to go another standard deviation, so another 5. So 24 plus 5, 29. And then add 5 one more time. 34. Okay, and then now we have to go to the left. So as we go to the left, what operation would we use? Good, minus 5. You said that so like, duh, Miss Morrell. Minus 5.
That is what it sounds like.
All right, what's 19 minus 5? 14. Okay, minus 5 again. 9. And minus 5 again. 4. Okay, so what this means. Okay, I know you did the math. That's great. That's what you're going to have to do on your practice. So, yep. But what this means, if somebody asked us, how many chocolate chips does a cookie have from Chips Ahoy? What we could say is on average, how many chocolate chips were there? 19. But we could say that most cookies have between 14 to 24. If you picked a random cookie, it's likely to have between 14 to 24 chocolate chips. Did any of you yesterday have a cookie between 14 to 24 chocolate chips? Yes. Do you have more than one cookie or less than one? Or more than one or?
How many of your cookies?
Yeah, sure.
Did you have more than one that was within that standard deviation? Like, for example, I don't know if this is what's a good one to do, but all 3 of mine
Yeah.
were within 14 to 24.
But was everyone's in between 14 to 24? No.
No.
Ian had a crazy one. What was yours, Ian? Yeah, you had like 5, right? Okay, so then if somebody's like, okay, but I want like a bigger guarantee, 14 to 24, you could say, okay, I could almost guarantee that it's between 9 and 29. Okay, I wouldn't put any money on it yet. I wouldn't bet on it yet, because this is where most of the data is going to be. Between 9 chocolate chips and 29 chocolate chips, that includes almost all the cookies. If I wanted to guarantee, like put a bet on it, like I bet you, if you grab a random cookie, I could almost guarantee it's between 4 chocolate chips and 34 chocolate chips. Okay? Did anyone in here have a cookie with less than 4 chocolate chips? No? Did anyone have a cookie with more than 34 chocolate chips? You did? You did not, you liar.
Why ask me?
You're not telling the truth. All right, so that tells us that that's our guarantee, that if Chips Ahoy was going to make like a statement saying, we guarantee this many chocolate chips, they would say, we guarantee there will be at least 4 chocolate chips in every cookie. Now, that's not a great saying. Okay, probably want more than 4 chocolate chips, right? I would think. Okay, but they could guarantee that there's at least 4 in every cookie. All right, cool. I'm going to stop talking now.